right, well, welcome everybody. I am MC Toon, the world's worst rapper, and I have with me tonight Earth is Seriously Flat. How you doing, buddy?
Fantastic. Just another blessed day on our beautiful stationary flat Earth. How you doing?
I'm great. I'm great. I got to go. I was at a Nicaraguan birthday party just before this, so we saw a piñata get crushed, and a bunch of kids.
Fantastic. We did crush a blue marble piñata on my first meetup back in 2015.
Yeah, it was a pink unicorn today.
Oh, wonderful. Hey, so when did you jump back into the spinning ball? I know you're a closet flat earther.
I don't think I ever was, but I
Oh, you've never been able to jump off the demonic spinning ball deception?
I've always been all my
You've always
life.
been a baller.
Yep.
A narrative.
I've got,
So
I
you
got
do
this
you
guy
know the
here.
narrative 100%?
I can talk about it, sure. So
I
yeah.
would love to know about your narrative. I know how far you went down that the glove light narrative, the doctrine. You could go really deep.
I suppose. I suppose I can.
How deep
So,
are you on the spinning ball indoctrination?
well, I don't think it's so indoctrination-y, but
Oh, is
I'm
that
pretty
original
convinced.
thoughts? That what you know is what you research?
Yes.
Also, you know you're on a spinning ball because you actually have scientific evidence of a Big Bang.
No, that I think is a little bit outside of the scope of the ball.
That's the beginning of your narrative, bro.
I don't.
You're
I
behind the
disagree
curve.
on that. I think it's a little bit of a straw man, because I don't think the Big Bang is integral to identifying the shape of the Earth.
The whole narrative starts with a big bang, dear Glove Zombie. That's how it starts. Not to, no, don't take it as an offense, brother. You know, they call us flat earthers, flat whatever. But I just like to call everybody that hasn't been able to really give me a scientific evidence of the Big Bang. I call them Glove Zombies because that's the number one part of the narrative.
I never, I don't really have a big care either way about that myself. But I don't
But you
see
think
it as a absolute necessity myself. But that's fine.
Anyway, well, so
Yeah.
you don't have a scientific evidence of the beginning of your spinning ball, right?
I
Just want
don't
to be
think
make sure.
I don't think that's a necessary part to identify what we're on. Right.
Right. But that's part of your doctrine. I just want to make sure that you understand that.
It's not. That's a straw man. So don't just put that on me. It's not really something I think is necessary.
Okay, so you don't subscribe to the Big Bang, right?
I generally do. I'm okay with that, but I don't see that
You're
it
okay
has
with the
any
Big Bang.
necessity in either way. I could go with
Right.
it started last Thursday.
But if you subscribe to a fantasy, something that requires faith. That's why I call it doctrine.
Yeah, I don't have a whole lot of faith in the shape of the Earth. That's more based on
No, but you
evidence.
have
But
faith that everything started with a Big Bang, right? That's your faith. You believe in that.
no, like I
You
said,
lean towards that.
you keep trying to put that on me, and I don't really care.
Okay, so let's forget about that one. It
Okay,
sounds like you have no idea where the Big Bang began, or you cannot really back that up, right?
correct.
So let's just talk
Yeah.
about your spinning ball.
Yes.
Now, what's the number one evidence that you could demonstrate that we live on a spinning ball?
How about the horizon never rises to eye level?
Well, the horizon never. That's a pretty strong statement. What do you mean?
Well, I've never seen a picture or any measurement of any sort of the horizon rising to eye level. It always
Drops.
drops. Yeah, and it's when
It
measured.
always drops.
Yeah, when measured. and in fact it drops in the correct proportion as predicted by the globe.
And how far is the horizon? Let's say when you're at sea level.
So the drop at depending on how high you are is changes depending on how high you are, right? So at sea level it's very, very small, but it's measurable.
No, but how far away at sea level? Let's say you're 72 inches tall.
Okay.
How far is the horizon to your perspective, according to your doctrine?
How far away? So I was talking. I wasn't talking about how far away. I was talking about how far it drops when you measure it from eye level.
Well, my question to you is, if you are 72 inches tall, when do you start perceiving a horizon? At what distance? Do you know? You have any idea?
Well, that wasn't
because your formula claims that 3 miles, right?
So you asked me what for my evidence, and so my evidence is that it drops, right?
Okay, the evidence is that you could be also on a convex Earth, and it could also drop. You could be also on a flat plane, and it will drop a little bit. But not. It should drop a lot more if we're on a 24,000 diameter sphere.
Well, we can totally calculate that and test to see if it matches. Right.
Right. But right. Are you familiar with high altitude balloons? Have you launched anything?
I have seen a lot. I've seen a lot of the videos of the high altitude balloons, but none of them
how about the Red Bull, the very big famous Red Bull? Do you see that?
The problem with that,
all the discrepancies of that.
Yeah, the problem with that in relation to the claim that I'm making about the horizon never rising to eye level is that there was no measurement of the horizon dip or not in there. So,
but you still see it at eye level there. From the cockpit.
No, it wasn't measured, so we don't know where it was.
But it's just an observation that it appears to be at eye level.
Yeah, I prefer something a little more precise than it appears. So it appears isn't
right.
A measurement.
I'll tell you what, brother. It's like walking into a house, and you notice that there is a throne in the living room, and you notice that there is all this expensive gold, and there's all these servants, and there's plenty of circumstantial evidence that you're in a palace. Same thing with the flat earth. Flat earth defends itself. The more you look into it, brother, you start seeing that there's no curvaison, there's no measurable curvaison, there is no spinning of the earth. I can see that the sun moves at 15 degrees per hour, and that's it. And I can see also that the moon and the sun move in a perpetual lock orbital path around the North Pole. We can see that. We can see it on the spring. It's like a clock.
So
we have cycles.
So hold on a second.
The moon and the sun.
Let's go back to my claim. All right? Because I was talking about the horizon never rising to eye level, right? So we kind of got off topic. Right. So I have. Can you see my screen here? Yeah, I think you can. So I have on there a measurement of the horizon using a theodolite. Right, and this particular theodolite used is able to measure down to 1 arc second. I said this one. Some only go to 1 arc minute. The one in particular is an arc second, taken at...
Okay, and you're talking about, are you making that observation with a fisheye lens or with a linear lens?
With a theodolite. So theodolite measures angles, vertical and horizontal angles.
Mm-hmm.
So, and it's I have the coordinates on the screen here. It's at Williams Reset in Maine.
And how high was that? How high was that picture taken?
21.986 meters. And here is.
I gotta do the conversion. How many? What was that in
feet?
Oh, that's it.
Yeah, there you go.
Oh no, man! Come on! I seen pictures of the Concorde at 60,000 feet with the horizon at eye level on the Concorde.
Was it measured?
Yeah, you could see it
No,
when
no,
you
no,
go
no,
in
no.
Mark II. All
See,
the
this is a this what you're doing is we're looking through this instrument that's designed to measure vertical angles. That's its function, right? So here it is measuring, and you can see
but at
90.
22 meters is not that high, brother. So let's say if we double that, we're supposed to see double the drop. If we
No,
let's say
no,
four meters.
it's not linear. It's not a linear drop. It's a trigonometric function. So it's not just a doubling every time you go up. But if you let me get through it here, you see here 90-00-00. That's exactly 90 degrees, which means it's level, perfectly level. So this instrument is
Yeah, I agree
right.
with you. I see. I make those observations.
Yeah. So you see
Yeah.
the horizon did not rise, and now
No,
this
no,
this
and you can see a little bit. You can see that it did not really make any difference. But yeah, but when
no.
you do
So,
that in the Concord, you will
okay, hey,
also see
this is mine.
definitely.
You bring up your Concorde later. All right. So here is then the other side. So he takes the theodolite and he rotates it around and then flips the the telescope so that if there's any errors vertically,
Yeah,
it
right,
corrects it,
right,
right,
right.
and you
Yeah,
take the average of
I
the
seen
two.
that. I seen
Okay.
those horizons errors, especially that line, the 270 degree. It will realign in a November morning shot. Then you will see the water be at 270 degrees exactly. If you're pointing that telescope eastbound, and you do that shot in the morning, 6 o'clock in the morning, as soon as the sun rises, then you will see that the horizon will level to 270 degrees. I did those observations, right? That
Okay.
doesn't mean we live in a demonic spinning ball.
Well, hold on. When it's your turn, you could bring up those measurements that you did.
Oh,
So,
I'm sorry.
all
Yeah.
right. So, I'm still trying to get through this, and you keep stopping me. So let's keep going here. So now he took then and he put it right on the edge there. You can see 269-52-10, and so that's the angle down. This is just one example. He took a screenshot or a picture through the theodolite of this, but he actually didn't just do these couple measurements. He did a whole bunch. He took all of his notes in his field journal here,
Yeah, I
and
see.
he comes up with at the end.
Beautiful.
He did 10 measurements on regular phase one and 10 measurements on phase two. So he did 20 total
Oh,
measurements.
that's nothing, brother. You need at least 360 observation, 365 observations to have a definite
And
know-how.
all right, so you have a citation for that as some sort of a requirement.
No, no, it's just because every day we see the horizon is at different distances. Every day. Doesn't matter what day it is.
Yeah,
Every day we
and
gotta have a different perspective.
so here's the cool thing. He did it. He did this more than once. He did this exact position two different times, and took measurements in the same quantity each time.
Okay, and what is but look, you are basically taking notes and taking this guy's word like it's God. Did you personally made any observations of why you live on a spinning ball?
Yeah, all right. So you're changing the subject here. Let's stick back to this. Okay. So if you doubt these measurements, then you're free to do it yourself.
No, I don't those measurements, but I done them year round, and it's always different. So in order to, and I'm working on tabulating every day at a lock distance, specific stationary target point, and that's what we need to see. You showing me just a line, and he could have manipulated that. I'm very skeptical at this point, due to all the fakery, NASA, all those
Well,
tricks, all those
he's
hoaxes.
not a NASA employee, to the best of my knowledge. He's just a surveyor. So anyway, so the thing is, every time this is repeated, the results are the same. Every time it's measured, the results are the same.
And just because the horizon drops, that means that it depends at different times of the day. That means we live in a bowl. No, it's variable. That means one day is flat, one day is curved. So that's
Well,
not consistent.
that's pretty silly. Of course, nobody thinks that one day is flat and one day is curved, right? So
Of
when
course,
there's
yes, of course you do. When you do daily observations, sir, you will see different horizons distances. One day on a hot day, you will see the horizon is only a couple miles away. on other days you see that the horizon is at a 60 miles, 30 miles. I mean,
Yeah,
it
well,
all
of course,
depends.
this isn't measuring the distance to the horizon. This is measuring the angular drop of the horizon, a very different measurement.
Yeah,
So
but the drop,
you keep
no, the
conflating
drop,
them,
you
right? So
it changes.
let's not conflate my evidence here. Okay, so I'm saying that there's an angular dip in the horizon, and you keep talking about the distance to the horizon, not something I'm talking
Okay, how
about.
much is that dip? How much is that dip? Let me ask you that. How much is
The
that?
dip, 7 minutes 39 seconds, with a standard deviation of plus or minus 3 seconds. Right, and so I have just for reference, I have on my website. I'm keeping track of all the notes, and I'll keep track of your stuff too, so people can look at it. But the I'll put in the chat the actual. It's on mctune.net.
So there is a half an hour difference just in 22 meters. Wow.
No. These are minutes and seconds of degrees, not time.
Oh,
So
7 degrees. 7 degrees is
no,
half an hour.
no. 7 minutes.
How much? How much is an hour in degrees in your paradigm?
There's degrees, minutes, seconds.
And in your paradigm, in 1 hour, how many degrees you think that the sun travels?
You're trying to change the topic. I'm not talking about the sun traveling. I'm talking about the
No,
angular
you're
dip
just
of the
giving me a
horizon.
drop of seven. You're giving me a drop of 7 degrees, right?
7 minutes, 7 arc minutes,
Oh,
39
I'm
arc
sorry. I'm
seconds.
sorry.
Yeah.
I'm so sorry.
Yeah,
You're
and
right. Okay.
people get confused on that, and so I'm not gonna press it. But this is, and I prefer myself using fractions, right, decimals, but they do the surveying industry still uses minutes and seconds. So, anyway, so
Okay,
that's just
he's a
one.
surveyor. He's supposed to have the formula
Yep.
to measure the curvature of the Earth. And what's his formula
He
to
has it.
measure
He
it?
has
Because
it
according to
right. He
that,
has it right there on the screen.
is that corresponds to the drop that we're supposed to be witness at 8 inches per mile square or whatever formula official
Well,
formula you
eight
have?
inches per mile square. It is not a angular dip. It is a whole different measurement. So again, it's not
I
the
understand.
right
What's the
topic.
official?
So here he has h times cosine alpha over 1 minus cosine alpha. That's the radius, right? So then he has he does the math there and comes out with a diameter of, where is it? Using 4/3 r and 7/6 r for the refraction. 24,102,759 feet for the 4/3 r, and 27,586,679 feet for 7/6 r. So pretty close. They're not like you identified. It's a single day measurement. So you do want to do definite more to get a better better numbers. But that's just one. So, and the point of it all really is that the horizon never rises to eye level, and that can happen only on a sphere. So this is on the bottom of this page is the video that he made for it, if anybody wants to watch it.
Great.
So that is my
That is your
first.
number one.
Yeah. Yep.
Number one, but he doesn't give you, according to that drop, the 7.25 minutes arc minutes. Does that correspond to the drop of what distance we're supposed to see? Let's say if there's a lighthouse in that example that you gave me at 30 miles away, and the lighthouse is 500 feet tall. How much of that lighthouse we're supposed to see according to his experiment with the 22 meters high observation?
Do you have you want to do a specific one?
Yeah, no,
Yeah.
in your example, how much of, if he's looking into the horizon now let's say 30 miles, and there is a lighthouse in that horizon, and the lighthouse is 500 feet tall. How much of that lighthouse would I be able to see if we live in on a spinning ball?
All right. Well, let's run the numbers again. What's the observer height?
22 meters, like you said.
All right. And what's the distance? You said
30 miles.
30 miles. Man, you're mixing.
And 22 meters is pretty high, actually. 22 meters is actually what did you have a conversion calculator right
Yeah,
there
I'll
to
do
see
it.
how much it's in feet, please?
Let's see.
Because if for example you bring in that at number one, that's where you live on a ball, the drop of the horizon at 22
Now,
meter
yeah.
high
Do you
observation.
have an observation? Because if we're just gonna, um, we
No,
don't
I
we don't
want
have
to
a
know if you
picture
know
observation.
if you can explain your. I'm asking you a question about your uh, proof that you live on a ball. I'm asking you not a question. I thought that was the format of the debate. Now I'm
Sure.
asking you: do you have any evidence of how much, according to your example that you're giving me right now, and so I'm giving you a hypothetical that if you happen to see a lighthouse that is 500 feet tall, how much of that structure will you see if you're 30 miles away?
All of it.
The
So
entire thing.
yeah, 30 miles away. Observer height 72 feet, and the target height is 500 feet high. So you see, well,
Yeah.
you see the top. You won't see all of it. So there's going to be a
Oh,
portion of
I
it
won't
hidden.
ask you the whole thing.
No, you won't. Not. You won't see the
How
whole thing.
much?
So 191 feet would normally be hidden.
Only 199 feet.
191, yeah.
191 feet. Oh, that's awesome. That's awesome. Do you have a link of that? The calculator that you have right there?
Sure. I'll put it in the chat. I like this one a lot because it gives the chart with the different refractions.
I love it because it kind of corresponds to some of my observations I'm doing in Sunset Beach, California. So
Yeah. Now, yeah, oh yeah, and then we actually have the lighthouse right here on the screen here. For some reason, everybody wants to view a lighthouse, so yeah. Wolfie 6020 always looks at the Bathurst lighthouse. So there were a couple super chats, and being that you are in the video, they're not from you, so that's a little unusual. I'm not used to that. So let's see. We got Aussie Globehead for $50 says Earth is seriously round.
yeah, round like a tortilla.
Dude, get me hungry now. Hold on. I just came from that Nicaraguan birthday party, and they did not have any tortillas. It's not.
No, tortillas are bad for you, man.
Yeah, I like to avoid them. So.
Yeah,
But,
try to avoid tortillas.
here I got the gato here. Here, let me put the screen here bigger.
I'll tell you what, brother. I'll like to, since you guys don't have any evidence of the beginning, I would like to share a little bit about the beginning, how the research, because the flat Earth or concave Earth or convex Earth, whatever Earth we're on, is just the rabbit hole, the starting point to going deeper into other subjects. And I found that I stumbled upon the history resets, Napoleon comets, and there's different amazing channels that talk about that static in the attic. Now, picture this, brother. Imagine a civilization where you go home and you have free energy, electrostatic energy. You have no diseases. There, there is propagation of all the vegetables around you. Everything is growing healthy. There's no diseases. There's no forced vaccinations. There's no wars. There's no fear porn that a meteor is going to hit you up in the ass. There's no global warming. There's no wars. Again, I said that already. But the bottom line is that we already had that civilizations where we all kind of work in a bartering systems. And that's what we find out. And we realize that the spinning ball indoctrination is just a way to desynchronize you with this beautiful world that we already, that is flat and stationary. Everything moves around us, whether it's a ball or whether it's concave or convex. We will find out as soon as we can go from north to south on the prime meridian. But for now, we know that the way everything started, it started by music. It's all vibrations. It started by resonances, and we have there is a beautiful video on my playlist in the beginning. If you go to my channel, you go see my playlist at the beginning, and you will see there a video about a star in a jar. This is a scientific experiment where they recreated, they resonated these frequencies into this jar full of water, and in the middle it collapses into, and it created this plasma event where we have light, a star in a jar. And the way I see where we live now, I see that everything started with a bang, but it was an instantaneous bang that everything came at once, different musics. Picture this, imagine your mother creator and your father creator making love and singing beautiful music in celebration of your existence, and everything starts germinating. The stars appear, the sun, the moon, we start popping out of the earth, different kinds at the same time. There's evidence. Ananda Bosma has done a lot of research about how anthropologists wanted to find out all the villages around our beautiful stationary flat earth, the oldest ones, and they realized that they were actually mapping the stars. All the ancient tribes where everything began on this beautiful stationary flat earth began in the stars. That's why when you check your astrology chart, brother, you can say, oh my God, that's me. Check your birth date, because that's who you truly are. And the stars, they're in cycles. Everything repeats. So we're not an expanding universe like they hypothesize, their theory of the Big Bang, and then the humanity exploded out of a chim's butt after a Big Bang. That's wrong, because we are divine. We are connected with this universe. It's all about music, on the 432 hertz music. And there's plenty of evidence right there on my playlist that you can really look into it. So do you have any questions?
Yeah, so you said you're going to have some evidence. So what evidence?
It's on my playlist.
I have the video, the Secrets of
Right
Cymatics.
there,
Do you
right
want to do
there.
that one?
Yes, play that for the 5 minutes. For my 5 minutes.
Okay.
From this,
Get to the bottom
this
of
image.
this.
This is not something that's been made in Photoshop.
Can you hear
this
it?
is an actual sound image in the water.
No.
No?
You
Oh,
can't
there
see
you go. I hear
the
it.
boundary
Okay.
condition because it was removed. That part was removed photographically, but there's been no retouching absolutely of that image. That is a real image of sound in water.
Yeah, he's talking about
Because
that.
it's a
Our, for example,
22.2,
let's pause it a little bit.
hertz
He's talking
frequency.
about this shape. With the shape that you see in there, right? It was made at 22.2 hertz.
Is that a physical object, or is this just like an animation?
No. There's no animation. This is a real image, was taken on a very expensive Tetra dish for scientific experiments, and they took this from the bottom up. So the camera was underwater when it took that image, and it's called it's a cymaglyphs. And these cymaglyphs are perfectly. This is not a CGI picture like the blue marble, the famous beautiful blue marble. No, this is a real. This is no Photoshop. And if you're looking for a model of our beautiful stationary flat Earth, this is what we are. This is a constant resonance, and there are formulas where you could calculate, and everything resonates at a specific hertz, just like the Earth. The Earth resonates at. Do you know the resonance of the Earth, by the way, of the blue marble?
I'm gonna guess that it's 33.
No, 7.97, almost 8 hertz. That's the 8 hertz per second. That's actually the binding force.
Dude, Russian vids would be very upset with you right now.
Russian beer?
Yeah, he loves 33. So, all right, I'm sorry. That was off topic.
Yeah, it's okay. Yeah, I love 33. I live on a 33-degree latitude here on a beautiful stationary flat Earth.
I'm at 45 on the spinning ball.
Great. Anyway, let me ask you one thing, brother.
Yeah.
About the spinning. What's the best scientific experiment you could share with me that I can teach a child how to prove that they're living in a spinning ball?
Well, you went over this with Team Skeptic, didn't you? He said he the same thing I'm going to say is you can do it yourself. You can do the Foucault pendulum yourself. So.
And how is that going to tell you that you're spinning with the Fulcrum? Because Team Skeptic didn't have an answer. To the spinning ball.
Did he not? I thought he did, but I thought that came up during your.
No, he talked about something that somebody else did. But have you done an experiment with the Fulcrum? Have you understood? Really looked into that really deep? What is really doing a pendulum?
I've not done it myself, no. But
have you seen one yourself?
I have.
And how the kick started every morning?
Yep. But the swinging part of it isn't the deal, right?
It's not correlated. Is that because if it's swinging at a particular rate, it's supposed to correlate with the spinning, right? But it never does.
No, it's actually the swinging is dependent on the length of the pendulum, and that's it. It doesn't matter how heavy it is. It doesn't matter what it's made out of. It's how long the pendulum is. That's what determines its period. So then it's once you start it going, it rotates as it's swinging, and that rotation you can measure it. And you multiply by the cosine of your latitude, and then multiply.
I'm familiar with the formula. Yeah, that's right.
Multiply.
So
by
how fast are you spinning at your 45 latitude?
At 45 latitude, it is.
Yeah, how fast are you spinning at that latitude? You're supposed to know that on the dime, bro.
No, I'm not. I have to do the math on that. 707 miles an hour.
Oh, okay. Well, you're supposed to say that instantly. You took too long. That means you need to research it. I don't think you're a serious blue marble defender.
Sorry, I don't have the cosine tables memorized. Do you? I don't know anybody that has the cosine tables memorized.
Well, I kind of do, man. But the thing is that
what's the cosine of 60?
I like to test globe zombies because I think you guys are basically victims of the Dunn Kruger effect. That when you guys live in a spinning ball, don't even know how to explain it. You cannot even explain your narrative about the Big Bang. All right, the beginning. You cannot explain the beginning. I brought scientific evidence of the star in a jar.
Wait, hold on.
Beginning, and so you need to concede that I won the first one.
You didn't bring any scientific evidence.
Renee, you have scientific evidence of your beginning, and I don't.
Dude, you didn't bring any scientific evidence yet, right? We can keep watching.
What do you mean? What do you mean? The star in a jar? That's not scientific.
But that's not
evidence.
That's
my beginning. You don't have a beginning.
That's not evidence of a.
Welcome to your wonderful globortion.
Dude, you didn't. You didn't do anything yet.
I have presented. For example, I show you. You know about the experiment of a star in a jar, right?
Yeah, I've seen that kind of stuff, but
okay.
but it does not follow that is what caused everything.
Okay, now I'm showing you right now the semantics that we live on a quasi holographic universe. That the
Oh, I would love to see the
videotape that you
evidence for
play right
that.
now. Play it for 5 minutes right now. I'll
Okay,
wait.
all right.
And because it's coming from an analog oscillator that has this very, very low distortion, we can draw certain conclusions. Let's imagine, if you will, that we can zoom in on one water molecule in any part of that beautiful, what we call a cymaglyph, you know, the word that we've created to say effectively sound image. If we could zoom in on any one molecule, what you would have to find is that molecule is vibrating at 22.2 hertz, obviously. And if you went anywhere else on that image and they zoomed in, you would find the same thing. Well, what does that mean? And yet we've got all this structure, this beautiful structure, you see? So this is why I think it's quite safe and conservative to say that it's holographic-like, or that we could use the word perhaps quasi-holographic, but certainly there are holographic properties to this. But another very important aspect to this is if we can create these kind of beautiful patterns in water simply by injecting a frequency or frequencies into the water, then there are huge implications for medical science, if you think about this. So it means that all of the sounds around us, whether it be people talking or music, if you imagine classical music, what that's doing in your body, this kind of image could be appearing in the visceral waters of your body, where you've got boundaries. Certainly, wherever you've got a boundary, you're going to have images that can form. Now, one of the areas in your body that you absolutely know you've got nice clean boundaries are the membranes of cells. And in fact, I have done some early work, microscopy work, with living cells where you can literally see the pattern on the surface of the cell. So just thinking ahead a little bit about the possibilities for sound therapy as a mechanism, that we're looking into a mechanism, why does sound heal? We know it does. Ultrasound is used every day in hospitals as an actual therapy, not just, you know, for diagnostic tool, but as a therapy. And yet no one knows in the medical community why that ultrasound heals. And there's a whole group of people, including my dear friend and colleague Gary Buchanan, who's speaking next, who uses sound therapy on a daily basis. And I'm sure he'll give you some more insights into this. But I think you can see that if we can create beauty in the body of the water, not just on the surface, then there's a big implication here for many aspects of science. The holographic principle itself, there are many, many definitions. I like this particular one by Zimmerman Jones. The total
All right, is this going to somehow be evidence that the Earth started from this yet? Because this is just showing, you know, that they can do things in water, which is cool, but I don't see how it's connecting.
Well, it's connected. It's giving evidence that gravity does not exist. It's a quasi-holographic universe. It's amyglyphs. It has to do with vibrations. It has nothing to do with your magnetic.
Okay, so all right, you're going to present that then, or is that in this video coming up that somehow connects those in? Because I'm not seeing any connection yet. This is all, you know.
You don't see the connection. For example, let's put it this way. But you don't see it because you're running your head, your glove zombie mind is fixed to the 24-hour time system. The real flat Earth time system is 18 degrees every 72 minutes. Therefore, you have a perfect 20-hour day. For example, 18 degrees before the sunrise, which I call the sun appearing, because it appears from the vanishing point. It appears at 72 degrees. If you have a compass.
I do.
So,
I do.
Okay, fantastic. Pull it out. What do you think 144 degrees is? What hour do you think it is?
What hour? Yeah, you're gonna
144 degrees.
Just do whatever you need.
Because
there.
what we're doing, all I'm doing here, I'm actually making a transition from degrees to hertz. So if we place the map of any map, we put it on top of this count, it's going to match. Let's say if you were to make a wristwatch that works on the 18 degrees, 72 minutes hour, it will work almost like a sundial. Because that's my proof that the Earth moves. It moves in perfect alignment and synchronicity with music, the music of love. For example, 72 degrees, very important.
So
Why do I do that?
hold on. You just said, I don't know if I heard you right or not, but you just said that the the Earth moves. So
No, the sun moves.
oh, okay. I
The
thought
sun
probably
moves at
misspoke.
17
Okay.
degrees, so the Earth does not move. No, the Earth is stationary, and everything. For example, have you ever heard of the Vedic Observatory in Iowa?
The Vedic Observatory.
Observatory in Iowa. This is here in the United States.
Hey,
This is the
I'm in
that have-
Minnesota. That's not far.
Yeah, you gotta go check that out, brother. I'm actually thinking of buying some property there. When I found out about this, it's actually a city of flat earthers.
There, Zion, Illinois was for a while too.
Right. Well, all the Mormons are actually flat earthers. They don't tell you because there's just a branch of the Masonic faith. But I'm correlating music with the movement of the sun, and the sun is actually singing for us. The sun and the moon are on a perpetual orbital path, performing the beautiful analemma, which is infinity sign of on top of us. And it happens. The moon and the sun are brother and sister, and the moon is actually the perfect calendar. 1,640 days. It's a perfect 4 years. We should be running all our life on the lunar calendar. So what we're proposing here is a breakaway civilization. Drop the 24-hour clock. That's bullshit. It's desynchronizing you. You are desafinado. That means you are out of tune completely. You need to reconnect to the 20-hour, which is actually the same as the Aztec calendar and Mayan calendar.
So, are you suggesting to switch your sleep schedule to a 20-hour day and have it always changing?
Everything, yeah, just like the Kodak guy. I don't know if you're familiar with the guy that made all those Kodak cameras. He was running all his employees on the 20-hour system.
Okay.
72-hour. Imagine if your boss tells you, take a 72-minute break.
All right. So, I'm still not seeing any evidence here for how this somehow started.
Well, the evidence is synchronicity, brother. There is too many circumstantial evidence. What are the chances
album by the
that
Police
the sun
called
and the moon
Synchronicity?
appear to be the same size? That they're in a lock orbital path, they're performing the analemma, and they are orbiting around the North Pole at 18 degrees every 72 minutes. Your heart, when you are in love, it beats at 72 beats per minute. Let's say when you're hugging your chihuahua or your bunny, your heart, if you check the palpitation of your heart, you're going to be in love. And perfect temperature, 72 degrees. There's too many coincidence for it to be fake. Okay. The blue marble pseudoscience is all about 666. We're supposed to be tilted at 6.6 degrees, right?
It's actually not. No, that's not correct.
How can you prove the tilt?
How can you prove the tilt?
Right.
Yeah, I haven't. Sorry, I can't prove the tilt.
Okay, so you can't prove the Big Bang.
But you claimed it was 66.6.
You can't prove a curve rise.
So, well, I can show evidence of a curved horizon if you want to see that.
Look, like a curved horizon. Okay, so you mean to tell me that you're going to show me a picture with lateral curvature?
Yes.
Not just a drop. Okay, so the 90 degree, you do prove that there is a drop at that when you show making those observation. But that's not a 1 year observation. But I'm just gonna give it to you, okay? So now the next one. What evidence do you have that there's lateral curvature? When you look at, let's say on a window, let's say you see the horizon on the window. At the window is
So
100 feet.
yeah. So all right. So I'm sure you talked about the high altitude balloons and pictures. People talk about one of the first.
Yeah, but
things,
those are fisheye lenses. The Red Bull is fisheye lens. Big
absolutely. So you and actually every lens has distortions in it. Even very expensive rectilinear lenses have distortions.
Yes, I agree with you. Yes.
So
why do they have to, on purpose, bring such an exaggerated fisheye lens?
Well, the fisheye lens, if you're familiar with optics, the fisheye lens is so that you can get a wide angle of view, and there's really no way to do that without. So, I just read a comment. I'm sorry, from Kristen Frost. Laser beams. I said rectilinear, not rectal. Kristen. I expect.
You know what?
Expect
We
that
need
from
a
guys.
rectilineum, brother. Hey, we need to team up, bro. Can we build a rectilineum?
All right. Hold on. All right.
Oh,
so,
a rectilineum.
yeah, she's acting like a 13-year-old boy. Kristen, I can't believe you.
Hey, you know what, brother? I went yesterday. I went to a free, for example, when you experience zero gravity. Have you ever experienced zero gravity?
I have
Weightlessness?
not. Have you?
Yes. My wife took me to this amazing place where you actually experience weightless. They put you in this
the vomit
solution
comment?
of water.
Oh.
This is they put you in this vessel and you're floating on this liquid that you feel there's no pressure points, and I realized, oh my God, those astronauts are not floating on zero gravity, because if you're just hanging, you feel the tension and you're tense and you try to keep balance. But when you truly in zero gravity, brother, weightlessness, when you don't feel anything, no pressure points, you get a big boner, man. No joke.
Hey, family friendly, buddy.
Seriously. No, but seriously, I never seen those guys in the ISS with a boner. Seriously, no joke. You're supposed to have a boner.
I do remember seeing the movie Moonraker, and at the end they're pulling the shade down, as James Bond is often does. And did you see today they announced the next James Bond, and it is going to be Daniel Craig again. So I was excited. I love James Bond. So
I love James Bond. They put a girl in there.
No, that must have been a rumor or something, because they confirmed today that it's Daniel Craig again, not a girl. So you know what? I kind of got distracted. I need to go back to Super Chats, because John Rapp said, "G'day all. Is he from down under? The only time the ocean horizon is at eye level is when you're eyeball deep in the water." NA for $6.66. Hail Santa. He said it's definitely a globe. And then Earth is seriously flat. I love that guy. He's awesome. He says, now I'm going to disagree with this, but he says love is teaching globe zombies they're on paradise. Brainy Beaver for $5 Canadian, which is basically Monopoly money. And then it's I can't read French, so sorry. Anyway, then John Rapp says Brainy Beaver must have dropped a tree on his noggin. Call a wambulance. So sorry, Brainy Beaver. Foxabillo says that's about 3 cents. So all right. And then Earth is seriously flat. Love that guy. He said, just now, love is bombarding children's websites with flat Earth. And I disagree, but that's fine.
But you know what, brother? I agree with bombarding children's websites with flat Earth knowledge. You know why?
Tell me.
Because you always have to see the other side of the coin.
I'm,
There's always the other side of the coin.
I'm great. I do love that. I love exploring it. And what I've done this last year and a half that I've been doing this, or more than that even, I've learned a lot. Um,
That's right.
and it's
It
been
opens your mind.
it's yeah, absolutely. And I write software, but I studied electrical engineering, and so I haven't used a lot of that since I was in school. So it it's been good. It's been really good to get back into some more of the higher end physics stuff. Um,
That's amazing. You know, I inspired one of my nephews. I enticed him with a flat Earth a few years ago, and now he's a rocket engineer, and he's making $200,000 a year.
okay,
A
so
flat earther
how does
working with aerospace
so
engineers.
are you
He's a rocket
all right?
scientist, our first rocket scientist in our family. Unbelievable. I have a lot of rocket scientists in the family, but
How so hold on.
I wanted to stop this kid
Is he you
to
say he's a flat
swallow.
earther? Where does he work?
He works in San Francisco,
Okay.
and
I
Adam Castiel,
yeah.
and actually he's an amazing, very smart guy, and he got himself working with the aerospace, rocket science, and even though he's a flat earther, and that's what's happening. We know we're not trying to stop. For example, when I found out that there was no Santa Claus, I was really
What?
traumatized.
Dude.
Yes. Seriously, man, I really, but when I start doing the math, I go, wait a minute, his big butt would not fit on my chimney. And that's what's happening. We don't, and people making a lot of money with the
Oh,
Santa Claus industry, and people
dude,
are making a lot of money with the shuttles,
you
with the
just wrecked
SpaceX.
you just
I
wrecked
bought
Brainy
a
Beaver
car from
Stadium.
that guy too,
You drive a
and
Tesla?
but yeah, but those we're not trying to stop progress. If this Elon Musk, he's a smart guy, and he knows is he just rockets to nowhere, no problem. He knows he's never going to Mars. He knows he's never going to Venus or Uranus. He knows that.
Hey,
But is the bottom
he
line
ain't
is
going to
that
my I can tell you that for sure. I mean Uranus. Uranus. He's not going to Uranus.
but the bottom line
There
is
you go,
that
Kristen. I can be a
people are
13-year-old
making a
too.
lot of money. I mean, I got stocks with Tesla. I mean, I buy their products, and whenever they're ready to go to the moon, hey, I'll be the first one in, and I'll bring a camera if they'll let me to show you the shape of the Earth. But we can't get that high enough. Like I was showing you on the video of the semantics, how we actually see it's not a CGI picture. It's an actual semi-glipse they call it, because we are in a quasi holographic universe. The laws that govern us are vibrations. The binding force of all our molecules is at 8 hertz per second. You know that, right?
Nope.
Well, there's a guy called Ananda Bosman, and they talk about hadronic mechanics, and it's completely different from the Einsteinian that's never done anything for humanity. And they talk about hadronic mechanics. Dr. Santelli in Florida, he developed a gas. It's called the magna gas that they can neutralize nuclear waste. Right now, we could get rid of all our nuclear storage facilities and convert it into a magnetic gas. This is all with the frequencies of love. That this is product of byproduct of all the waste that we could recycle, we could develop a gas that can burn faster and harder than anything, but will not burn human flesh, because we are made is something much more complex. Uh, we don't know what we're made out of, but we basically, I believe that we are co-creators, and especially when we synchronize with the movement of our sun. Let me give you an example. When you travel to New York and you have to adjust to the jet lag, you have to adjust to that time zone. Same thing. You need to adjust to all the movements of the stars. You need to be able to travel
All right.
on
So
this beautiful.
so hold on. You said he can with his gas he can turn nuclear waste into love. Can you explain that a little more?
He can make nuclear waste into magnetic gas.
What's a
Is
magnetic
the
gas?
byproduct of burn. Magnetic gas is a fuel. It's a gas that you could burn, and it burns faster than anything a welder has ever experienced. And this is new technology. This is hydronic technology, hydronic mechanics they call it actually. And the doctors can
All right.
tell you
So
could.
so
It's
if I
magna
take
gas. You
this
can even buy stocks for magna gas,
if
magnetic
if
gas,
I take
but it's called
this
magna gas.
this magnet here, will the gas stick to it?
Yes. Actually, the gas put the gas inside of a balloon inside of a container.
Okay.
The pressure, yeah, and then the balloon will stick to a metal. The
So
gas
this
is
is
actually magnetic.
a ferromagnetic gas.
Correct. Yeah, magna gas.
Oh, there you
And
go.
that's what flat earther. And he's a hardcore flat earther. He's in the he was here a few years ago, along with Ananda Bosman here in Los Angeles, California. Ananda is actually staying in my house, and they talk all about this. And this is the guy that talks about the frequency 432 hertz, which is the frequency of love, interdimensional. When you learn of these frequencies, you become a genius, actually. You teach your children these frequencies. This is the same frequencies that before the 1930s, everybody knew about it. Mozart, Schubert,
You know, I recently
Baudelaire.
coincidentally looked all that up and read about it. You might want to do that too, because the information doesn't quite match what you're saying. But here's
The
a
432 hertz? The
here's
432 hertz? Do you
here's
know
the
a lot about
the
the 432 hertz?
yeah. So the magnetism observed
know of
in a
that?
gas for the first time. That's pretty cool. A ferromagnetic gas. I wonder if I could feed
Yeah.
that to my kid, and then use a magnet after he goes to the bathroom. What do you think?
You actually, if you use that for cooking in your home, you create more oxygen. You'll feel like you're in an ozone area and
It creates more
disinfecting
oxygen.
everything.
Oh, hold on a
That's
second.
right.
The gas only works at 150 billionth of a degree above absolute zero. That totally won't work for the bathroom scenario. Crap. All right.
That's what I'm
That's a
saying,
pretty
brother,
limited-
because what happens
pretty
is when
limited
you live
usage there.
in the narrative of a blue marble that you are aimlessly
Okay.
towards a black hole, you very skeptical. You don't really make plans for the long term. For example, if I ask you, what do you see in the next 50 years in this spinning ball?
What was that again? I'm sorry.
What do you see in the next 50 years on the spinning ball? What do you see humanity is going to be at in the next 50 years?
In the next 50 years? That's a good question. I'm not
50 years ago, they told us, oh, we just got into the moon. Now we're going to have 50 years from now, we're going to have moon bases. We jump
Dude,
to Mars.
4 years ago we were supposed to have flying cars and skateboards, and it totally didn't work out. You know what I'm saying?
You know, the thing is that we're never going to have the true technology that we had before. There is evidence that there were trolleys that were running with electrostatic energy all over in different cities, even in Mexico City in the 1800s. But they took that down and they switched it to Edison bullshit. But yeah, we could have a world like Tesla says. I don't know. I actually bought a Tesla coil, and you could actually send electricity wireless, and like the Lewandowski oscillator.
That's how I charge my
Actually,
phone.
What was that?
I charge my phone wirelessly. There's a inductive charger in it in the back.
Right now, imagine if you were be able to drive your Tesla X with electrostatic energy, where you don't have to stop after 300 miles and recharge. How would you like to have that. No need to charge anymore. No need for batteries during the. I don't know. I mean, I think that sounds like a pretty good deal for everybody without worrying about diseases. Without
Yeah.
imagine once with flat earthers take over this world, whether it is round or not, we are gonna be able to bring technology that has been sequestered from us. We want to have all those patents released. We want to have all the Tesla books released. We want to have all the technology to heal us. It's enough. All this fear porn that anytime a meteor can hit us on the ass, anytime we're gonna die, any global warming, and global warming, by the way, the climate change bullshit, there's the climate gate.
Hey,
They got caught with their
I do
pants
like
down.
I do like to keep it kind of family friendly. So if you can watch that
All
a
right,
little bit, yeah.
sorry, yeah.
Yeah.
But we're victims right now. They stole our future, and right now they're going off on with all these DEW, the direct energy weapons. That's how they destroyed the 9/11. Oh, by the way.
Oh, hold on a
the
second. No,
9/11
no. We're not talking about 9/11.
Okay, well that's the actual proof of the.
All right, hold on a second. Yeah, I took you out because I'm not going to talk about that. I'm not going to talk about 9/11. So they didn't hear what you said there. Okay, so if you go there again, I'm gonna. Yeah. Yeah. All right. Well, put that out on your channel there. Okay. So.
And all your subscribers to go check out my playlist on the beginning, and you will see a lot of the evidence that we have of our beautiful stationary.
Yeah.
battery.
All right. So we've done. You did one. I did one. It's my turn again. Right.
Go ahead.
All right. So you want to see. You say the Curvizon.
But before that, you have to concede that you didn't have any evidence of the beginning of the spinning ball narrative, right? You don't have any evidence of that, right?
Neither of us had any evidence of the beginning of the Earth. Correct.
I
will-
show you this evidence of solar luminescence with
you-
the star in the jar.
You
And
showed me
that's a
that that
scientific
happens.
experiment. And also these resonances, that's physical, that's not CGI. I got two examples right there. You cannot deny those two examples right there.
Well, I'm not
You could play
denying.
the star in a jar on my playlist too and show
Yeah,
them.
I'm not
to the
denying
whole
that.
next topic.
I'm not denying that it happens. I'm not denying that sonoluminescence doesn't happen or anything, right? What I'm asking is that, or saying is that there wasn't any connection between that it happens, and it is what caused the Earth to
It's
come into
happening.
existence.
Yes, it's
Yeah.
happening right now.
Yeah. So, but there's no. It's a complete non sequitur. They're not connected. You didn't somehow connect them. So, neither of us brought up evidence for how the universe
I did
began.
connect it. If you don't understand it, that's another thing. But you have to concede because we talk about the beginning of the show. We were going to talk about the beginning, and you don't have it. You don't even know where the spinning ball narrative began.
Well, I don't think that's true. But it's not something
Okay,
that
well,
I
it
need to
began.
talk about, right? So,
Where did it begin in the beginning of your spinning ball narrative?
how about my turn to bring up evidence?
Okay, go ahead.
All right,
Go ahead,
so-
bring your evidence.
Yeah. Oh, Brainy Beaver. Don't say non sequitur. I'm sorry. A little too soon, people. I know. All right. If you say it 3 times fast, Cal shows up and takes your YouTube channel away. Yes, please. I won't say it any more time. I'll say Beetlejuice, Beetlejuice, Beetlejuice instead. So, all right. Let's see here. So, when we look at balloons that have lenses that are, even the ones that have been replaced with rectilinear lenses, they still have distortions. So what you need is like when people just point their camera out of the window of a plane and say, "Oh, look, the horizon drops." It's not measured. We need an external measure of some sort. So there's 2 ways to do that. One is you can measure the actual distortions in the camera, and there's actual software that'll do that. And you can, if you want, you can write it yourself in Python, or you can have a physical external straight edge or something like that, right?
Right.
So and then you put that next to the horizon, right? You put it straight across, and you put it near the horizon, and then you can measure it. So a guy named Rory did that, and here's what he did. This is just a picture of his setup here. So he's got this straight edge on the left here with zip tied together. You got a straight edge on top, straight edge on the bottom, and then he has over on the right side here, same thing, another straight edge.
That's not yours, the research, right?
No, it's not. No, and of course neither is the sonoluminescence. So if you're going to say I have to do it myself, then all of your sonoluminescence goes out the door.
I could do the resonance for you to hear them. That's all. But yeah, the sonoluminescence I need actually $200,000 per phone.
Yeah. So if you didn't do the experiment, I'm fine with that, as long as you're fine with me not doing an experiment, right? That's turnabout is fair play, of course, and science doesn't demand that you do it all, right? So,
correct.
All right. So what he did is he lined up and took a picture with the horizon between those, like this. And so here's the actual picture where you can see. I'm going to zoom in a little bit. You can see the horizon right between there.
Yes, I can see that.
So, all right. And then,
that's a clever experiment. So you're gonna show me the lateral drop, right?
Yeah, this is the left to right curve that we're gonna test, because we know the straight edge is straight. Now, we all have to take on faith, and so if you're concerned about this, you live near the ocean. I don't, right? So I can't do this myself. Minnesota's as far as you can get from the stinking ocean. But he did this at 600 feet elevation. Right, so now we can move left to right. Now you could count pixels, that works just fine, and then you can chart out the gaps on the bottom, gaps on the top, put it in a spreadsheet, whatever you want, and then but you can see here it's coming up a little bit. It's a little hard to see, but all this is on my website, and you can download the original pictures with the full EXIF information, the GPS coordinates, all that.
What's your website again?
mctune.net.
Oh, okay.
And this is /debate-11. And I need to put this, I'll get it after a bit here. So anyway, I'll keep scrolling to the right here. And Rory took a whole bunch of pictures because it's pretty difficult to get this lined up right. Keeps going. It kind of in the middle, it's the highest, and then it starts to curve back down on the right side here. It's difficult to see, but you can definitely count pixels and put it into a spreadsheet. Another way to see it is you can use image editing software, and you can do this yourself. I did it, and Rory did it, and I'll show you when you do a left to right compression, you can see very clearly what happens. You can see the curve now. So there you go. There is the curveizon, as you like to say.
Wow. That's beautiful. I want to try that experiment myself.
I love that you're open to that, because a lot of people just say, no, I'm not going to do that, and so I hope that you do.
No, man, this is an ongoing investigation. There was this amazing documentary called The Principle. Are you familiar with that?
Let's wait till we finish talking about this before we go to that.
Okay, go ahead.
Because
I gotta give it to you. You got a good point. This is very compelling. You got this one. I can see it. Yeah, there is a curveizon right there. I never seen a curveizon ever, and this is the first time I'm blown away. I'm gonna buy you a drink for that one. Whenever you're in California, man, come over here, man. I'll buy you dinner.
Well, thank you. I would. You know what? I would love to meet you. I was there in February, and I tried to get a hold of Bobby Shafto, if you know who he is, and we just couldn't.
Yes.
We couldn't make it happen. But he's a nice guy, and he's I don't know if you've dealt with him. He's always just super, super nice, and he's more patient than I am, for sure. So all right,
we should do a glove earth meetup, glove flat meetup. Glove flat meter.
Yeah. That'd be great. I'm
Being
gonna.
able to be together and agree to disagree,
Yeah.
or we all could agree.
Yes, let's all agree, and then we can move on with more important things like getting to the moon, man.
Or how about this one? How about if we take over back our planet? Because as far as I know, fake news and all this pedo wars all over running our governments, and all these perpetual wars, and all these chemtrails, and this forced vaccination, GMOs, and fluoridation of our beautiful waters. I mean, that's where we need to really unite, because whether it's a globe, concave, convex, there is some sort of an element out there.
Yeah,
That's not even in
there's
the
certainly
space.
things that aren't good. I agree.
Right.
So,
And I know the people that are debating us, all the globers defending the blue marble. I actually call them the blue marble defenders.
I like that better than some of the
Glove
insulting.
zombies.
Yeah, I don't like any word that ends with tard. I think that's inconsiderate. So
No, you know what happened is that the word tart was demonized, because tart is from the Tartarian kingdom. Are you familiar with the Tartarian kingdom?
I am, but that's a bit off topic still, right?
Right. But there was those were the people that were running free electric cities with abundance, with no wars, the Tartarians. That's why nobody knows about it. Anyway, and that's what I'm trying to get back to. You could call me flat earth Tartarian, because I want to go back to the golden era of humanity.
All right.
You know, when we could build cathedrals, not for religion, but to recharge the soul, and to energize, and to help us get along, and to, just live in a better world.
Yeah. All right.
But
So
seriously, brother.
yeah. Do you
Well,
do you
tell me
want to do you have something else?
Well, I just want to say that question everything, and whether you brought proof that very compelling about the horizon, and I'm gonna go do those observations myself. I have a place where we could do that, and I really enjoy talking to you, man. That's very nice. And we should. Right now, I'm in Santa Barbara. I'm not on my on my official headquarters, and I can show you more of this evidence. But take a look up Ananda Bosman, and just go to my
So
playlist.
all right, I don't want to get the name
look-
wrong. It's a little hard to I want to spell it right. Ananda. How do you
Ananda Bosman. Is
ANANDA.
ANANDA
Okay.
BOSMAN.
Okay, and this is a YouTube
Bosman.
channel?
Well, you can find it on the internet. It's
Okay.
in any search engine. But this is the guy that made the connection with the hadronic mechanics. That's why Dr. Centelli has been able to create a new element into the periodic table, which is magnetic gas. Something it couldn't be possible. And that explains the beginning. Who are we? Where are we going? And what are we? Where are we going? Where did we come from? And what are we doing here? And it actually answers the three primordial questions. And one of the things that when I realized that the sun is actually traveling at 18 degrees every 72 minutes, it puts you in a different mind frame. For example, would you like to hear some of that music that the sun is traveling around our North Star, the sun and the moon? Would you like to hear some of those frequencies?
Sure, that might sound interesting.
Listen to this.
I am interested in the new element.
little bit of that. So that's the music of love. A at 432 hertz.
Was that? Did you do that live? Was that like on a recorder or something, or?
Yeah, this is just a PVC pipe.
Oh.
They don't sell instruments on these frequencies because, like I said, they made it illegal in the 1930s. And I also have the flute that makes these, also the 72. The one that I show you is A at 432 hertz, and this one is at A at 72 hertz. That is actually on the same range. 72 hertz is same as 72.
That's 432.
432. Yeah. Listen to this. Yeah, that's the 288, which will be like the on the clock. If when you it's actually will be like 10 o'clock at night. 288 hertz. That's
how is 288 hertz 10 o'clock at night?
For example, in 5 o'clock in the morning, the 5th hour. I'm actually, because we're transferring, instead of 24 hours, we do 20 hours. So noon will be the 10th hour. We add 180 degrees. The sun, when the sun vanishes into the vanishing point at 270 degrees, that'll be the 15th hour. 288, which is the 16th hour.
All right. Well, hey,
so that's how we do it.
So
I'm gonna do if you search a little bit about the Aztec calendar, you're gonna realize that when you wake up in the morning, you don't just wake up and start working right away, do you?
Well, no, I gotta.
No, nobody does.
Yeah,
But
I gotta
reality,
transform from a bat back into a person.
You wake up and you have to do 72, just like the astrolabes. They were designed to wake you up at 18 degrees before sunrise. They tell you they have to pray, and praying is visualization.
How does an astrolabe wake you up?
Because it's the light. The way it tells, it's a guide. The astrolabe tells you that when you see the light is at the beginning in the morning, before the sunrise. It's about 72 minutes before the sun actually appears from the vanishing point.
But the astrolabe.
If you pay attention to this.
But how does the astrolabe wake you?
When the sun is, when you start seeing the light, you don't just see all of a sudden dark, and all of a sudden you see a sun. No, the way is gradual. And this 18 degrees, they're based into doing 72 minutes of visualization. You have to see, you have to manifest, manifestation. You have to see your whole day, how amazing you are. Then you do 72 minutes. Once you wake up, you do 72 minutes of action. And this is all been logged thousands of years. People know about this. And then they do, after 72 minutes of actions, they when, for example, you wake up, you do manifestation.
Hey, I have a question. Can we?
Yeah.
So the people in the chat are asking about magna gas. So what is magna gas made out of?
Magna gas is when they put this sludge inside of a canister.
But what's it made out of?
I'm about to tell you about what it's made out of.
Okay.
Okay, so this is it's actually like a portable refinery where you put remember the movie Back in the Future with a car they put trash into this container.
Yeah.
This canister.
Banana peel
Okay.
and the beer. Yeah.
So yeah, they produce a plasma event inside that canister.
Wait,
Once they lock it out, they create a plasma event, which is 10 to the minus 13, an explosion basically. Is this plasma event disintegrates everything inside of that.
What is 10 to the minus 13?
10 to the minus 13, everything graduates. For the center, in the spectrum, everything compresses. And 10 to the minus 13 is the mark when everything collapses.
10 to the minus 13. What's the units?
10 to the minus 13 into the compression state of things.
Whoa.
For example, it has nothing to do with calculus or this, because this is hadronic mechanics.
Is 10 to the negative 13 a positive number or a negative number?
Negative.
Are you sure?
10 to the minus 13, yes.
10 to the minus 13 is a negative number.
What happened is you
met
destroy this to such a degree, so small, that it destroys anything on its path, the magna gas, and it will actually be safe for humans. So that means that we are beyond what Einsteinian or quantum or string theory talks about. We are beyond all of that.
You were saying that you can put like nuclear waste into it, right?
Yes.
Okay. So all right. So then, like nuclear waste, like what you?
Let's say
to
from a power
230.
plant.
Yeah. So But you know what's in nuclear waste?
Anything that's toxic.
Anything that's toxic, or anything
for
that's
example, the
radioactive?
Fukushima event. If we were to take a couple of those mini refineries into these locations, where every time we have a catastrophe for oil spills in the ocean to purify, even we'll make more oxygen. It'll be better for the environment.
All right. So we take uranium, like uranium-236, right? And then we bring it to. All right. So I'm trying to get like I want to draw this out so I can understand it well, you know. So like you take U-236 with toxic waste, right, or whatever else, and then you apply 10 to the negative 13. How does that work?
No, that's called. Look, I'm not an expert on hadronic mechanics. That goes over my head. I'm not a quantum physics. I'm just a landlord and a hairdresser. But the thing is, just look into it. That's going to be your homework. I don't have all the answers. Otherwise, I did buy stocks with magna gas, and I'm planning to buy one of those little mini reactors, refineries. They're portable, actually. They're about $200,000.
Oh yeah.
You could sell that magnetic gas. It's amazing.
All right. So, is this the business plan?
Oh yeah.
Yeah. So all right. So got it. I'll got it. I don't know if that quite.
Yep. Yeah, something.
Something like that. Okay.
You're gonna be an amazing flat earther.
Yes, I think so. Is that right there? That's it, man.
Anyway, well.
I'll write the software.
No.
Yeah.
Right. Let me tell you one thing. Since you're a software writer, if I were to give you money to write a flight simulator software game, are you gonna write it on a spherical Earth or on a flat stationary Earth?
I would to keep it simple, because I'm a software engineer. I like to get rid of as many complexities as possible. So if I can do, like, I would first start with not having any wind, and I would also have no topography on the land to begin with, right, to make it easier to start.
No topography. How are you going to compensate for?
Well,
the
no,
different-
that's where I start, right? Then once you get like the simple models down, then you say, all right, so what are our next priorities that we're going to put our efforts into? Because every time you add more realistic things, the difficulty of the next step is always a lot harder, right?
I'll tell you, yes, you're right.
So when we're doing, we're planning out our software development cycle, we look at what we want to do, and we kind of come to some sort of a grand idea, and we figure, well, that'd take 10 people 3 years to do, and then we're like, we don't have that. Is there anything we can do to simplify to do it so that it would be quicker? And so then we work through stuff, try to figure things out, how we can make it so that it's easier to do.
Right.
So that it's.
But it's not about it's not about simpler, brother. I think if you are writing a software that the life is going to depend on, because you're not going to put the wrong model on them to train on, right?
Well, yeah, you have to evaluate, is every single thing that we add in what is necessary in order to give us the right calculation. So, for example, if I were doing a flight simulator software, I would not calculate the plane to have any flexing of the wings, because that greatly complicates all the calculations. So I'd say that there's no flexibility to the wings, and I would probably not even try to have any sort of there's people on this side of the plane and there's more weight on this side of the plane. I would treat the entire plane as a one uniformly distributed mass, or even more simple, I would just bring it down to a single point at the center of mass of the plane and say, well, I'm just going to calculate the location of the plane as just one single coordinate, right?
Well,
much
actually,
simpler.
Let me give you a little tip. If you were to really write a software program for a pilot, you have to put into account three things. Only three things are important. You have to make sure you are putting into account the pressure altitude, which is the standard datum plane. Are you familiar with that?
The standard what?
The pressure altitude is equal to the standard datum plane. Is the universal
the altitude is the
theoretical level where the weight of the atmosphere is at 29.92 inches of mercury measuring a barometer, something like that, but it's actually precise. So anybody that has a question about why planes never compensate is because everything is based on the standard datum plane, DATUM plane. That's what it's spelled.
Oh.
And also you have to take a look into the true altitude, because the true altitude is the one that is at sea level, and the absolute altitude, that is the terrain. Those are the three things, and it demonstrates perfectly that we live on a flat, stationary plane, brother.
Oh, well, are you going to present how that does that?
That's what everybody knows. Everybody that knows planes.
Well, but you just said you need to take these three things into account, and then you made this huge jump into, and therefore it's flat. So I'm missing the in-between part.
Well, you make those three things. If you think about it, the baseline of everything is just like you said. They made everything simple. So they base everything on one plane. And then you have three things you have to consider after that.
All right, let me write this down.
First of all, number one is the pressure altitude, which is the standard datum plane. That's everybody measures that. That's why if all your instruments on an airplane were to go belly up, you would really never need to compensate for curvature, because you're flying on a plane. and that's why they call it the standard datum plane. The
Oh,
sea level has
okay.
nothing to do with it, nor
So
the absolute altitude.
so I have one
To,
pressure altitude standard datum.
right. So
Okay.
that's what
And
the
then
universal standard of flying a plane. It's not a globe. It's not an air globe. It's an airplane.
it's not an
Welcome to your
plane, it's
wonderful
an
global show.
atmosphere. I can do that too. So, all right. So number
But
two.
look, all your books, everything that tells you about where we live, is on the books. Is
All right. So then this.
if you
What's the
buy a
second
book
one?
about how to fly, a handbook how to fly an airplane, it will tell you all of that. If you buy a book about surveying, it will tell you everything is about a plane. Everything's about a plane. Nothing, absolutely nothing, except when you're um, looking into the grid that they put us into the narrative, and it works. Everything works. Uh, Algorithms on a software to do piloting train on a airplane works on a flat plane.
Well, yeah. Like I said, when you're writing software, you get rid of the things that you don't need to do so that you can save time. If you're going to do things you start with the simple. You start with a Euclidean coordinate system, and you only move to a spherical coordinate system if it's necessary, right? Because the complexities of a spherical coordinate system versus a Euclidean coordinate system are way more difficult to do, so you try to not do that.
Well, there's different converters, GeoRef XY converters. I don't know if you're familiar with those. If you are in the maritime, I don't know if you ever tried to
No,
pilot.
I'm talking about writing the software, right? That's what you were,
Okay, all right,
right?
right. But the software, like I said, nobody has ever written a software living on a spherical Earth. Only Google is the only one, and we all know Google is the devil.
No, we don't.
Sold it resurrection.
I mean, there's plenty of
I
things I don't
shouldn't say
like
I
about them,
shouldn't say that, but
yeah.
we when you do searchers is usually, I don't know if you're familiar with the meta tags, right? Spider software where you put the meta tags and it ranks you number one, and if you tell them the truth, it correspond what's in front of your website. That you're familiar with all of that, right? How to rank number one on the
Yeah,
web.
yeah. So, search
Right,
engine
right. Well, they
optimization.
mess with all of that. The Google now, after the flat Earth, and this awakening, they have actually changed their algorithms in Google because they don't want people to really research flat Earth. Have you noticed that they're fighting flat Earth with their nails, man? They're throwing everything but the zinc at us. Have you
Well,
noticed that?
yeah, but there's no evidence for it, so it's just in the end, it's just annoying. Like if you go and you watch a SpaceX launch, and then there's some flat earther in there, yapping about it being flat. It's like, dude, could you just let us watch this and
No, no,
enjoy it?
no, no, no. I love flat tech. Like I said, that those launches, they're beautiful. Yeah, but those are just props. They're not good. These are rockets to nowhere.
There, are you suggesting that there is not a
What did they?
rocket there?
No, I'm saying that those are actual rockets that they launch with beautiful hard work, and everybody's making a lot of money. My family's making a lot of money on all this Tesla. I'm making money with Tesla, but the thing is that they don't go. I mean, 250 miles. It's not high. It's not deep space,
Well,
right?
they weren't claiming that, right?
Right. But they're not really going to the moon. That's why 50 years after they went to the moon, we still can't go back. And only Nixon, the big time liar president.
But the thing is that there is evidence. People have sent probes there. There's a probe on the side of the moon, so that the Chinese probe that's on the other side of the moon can bounce their signal off of it, and they're sending pictures back. So we've gone back to the moon, not with people, right?
Right, but I was hoping to see more people. I mean, they canceled the shuttle program.
I know,
What the
and
hell is that
that
all about?
Yeah, and that was sad, but I went to the third to the last launch of the shuttle. It was pretty cool. We were miles away. Have you ever been to a launch? Because you're not too far from SpaceX there, where they launch in California. But you can feel the heat on your face.
Oh yeah, yeah. No, it's amazing.
It's pretty
I've been
cool.
some, and I've been glove zombie for. I was a glove zombie for 50 years.
Yeah.
And,
So now do you know
now I
why?
understand. It's like when you go to a magic show, you see a lady, zero gravity. They levitate a lady on a magic show. That's all we see. It's just a magic. It's just a show. They're not actually doing anything.
Well,
You don't even actually see the garden.
when you go to a magic show, of course, they're not actually claiming to do real magic, right? It's a wink and a nod. Everybody kind of knows. But SpaceX is saying they are putting things in orbit, and so when Bangladesh paid all that money to have a satellite built, and then paid all the money to SpaceX to launch the satellite, right? So what happened? Because the people of Bangladesh, right, a third world country, pretty poor, they took their satellite dishes and they pointed it up to a spot up, above at the correct angle, and then their TV works and they get reception. So what is it? There's this connection, there's the satellite, there's the launch.
We're bouncing signals off the beautiful dome firmament. That's all we're doing.
So you have evidence of that?
Well, since we've been bouncing radio signals since the 1800s, right?
But do you have evidence that is how they're getting their TV signals?
Everything bounces off the dome firmament.
Yeah, that's just a claim.
No, it's you search. When was the last time? When did we start? Listen, I could do the search right now. Radio signals. First radio signal.
Off the ionosphere? Yes.
Guglielmo Marconi. That was in 1895 to 1899. He flashes the first wireless signals across the English Channel, and 2 years later received the S telegraph from England
Okay.
to Newfoundland.
Yeah, off
the
ionosphere.
I never got the memo when we stopped bouncing off frequencies, because every time you ask somebody that takes actually pictures of Mars with the rover, you ask, "Oh, what frequency did you receive that photograph? What, was it a JPEG? Was it GFI? What is it? What GIF? What is it?" They don't know. This is a secret.
What's a secret?
The frequency that they receive, what kind of format they receive the image, because it's not like you take a picture and you bring back the camera and you develop it. They're
Sure,
supposed
yeah.
to get in radio signals, right?
Yeah,
So
but JPEG
when you
isn't a
ask
frequency.
What frequency did they receive that specific? Because look, right now there's a lot of amateur radio interceptors that can intercept. If we're getting, let's say, pictures from the Himawari 8 satellite, and I would love to intercept those signals, but nobody can. Only them. Only one source.
Are you sure?
It's like, for example, when they said they
Are you
went
totally
to the moon,
sure?
people actually intercepted their line in Russia and all that. We don't have any second party correlating all of this. For example, they just found the latest news in the space. If you Google right now the space news, they say they found a star that is older than the Big Bang.
Oh,
So
you
the
didn't
only
read
thing
that
that's
right.
expanding in your theory
Hold
is
on.
your
Back it
imagination.
Back it up a second here. You didn't look at those numbers, right?
Of what? Would you please illuminate me?
So I saw that same thing, and the age of that star was a certain number with a margin of error, and the age of the universe is a certain number with a margin of error, and the margin of error is overlap.
You're right. You're right.
So
It could be the first star. That's what it means then. But like I said, your narrative keeps expanding and expanding. And in reality, we have cycles. We have, if there's a spring every year, there's always two springs every year, there's always two summers, there's always two falls, there's always two winters, there's always a cycle. We are in cycles. We're not on a expanding universe. Remember that and put that in your grumpy zombie head. You're not on a spinning ball. You're not expanding. I'm sorry to say
All
that.
right. So you said that every does the radar bounce off of the firmament then?
Everything, yes, everything bounces off the
So
firmament.
you can't like send
Uh,
radar through the firmament.
Any radio signal bounces off the ionosphere. I call it ionosphere. I don't know if it's actually a dome, but as far as I'm concerned, there's something. If there's a container out there, it's actually a container where it contains our 14.7 pounds per square inch of atmosphere here at sea level. We're in a container. We could actually be underwater.
The problem, of course, is
Inside
that
of a bottle.
there is a gradient.
Yeah,
Right,
You could
and-
you could have a gradient inside of a container too.
Yeah, but what's causing that gradient?
The density of the gas. In this instance, is the
But why is it more dense down low instead of
well,
the second law? Hold on.
because it doesn't push. It's not like it pushes you down. It's pushing you in every direction.
Yeah. So the
no-
the second law of thermodynamics, if there is no force pushing it down, says that it's going to distribute itself evenly within that area.
Correct.
Right.
I agree with that.
So why is it that at sea level there's a higher pressure than if you go up a mountain? You didn't go through any containers.
Right. Correct. It's just the density of it. For example, when you're going deeper into an avocado, as soon as you go deeper into avocado, you're going to find a sea, something denser.
Yeah, but what makes it? You didn't really answer why it's
For
denser
example,
down low.
Let's do this one. If gravity is actually pushing you down, right?
Yeah.
It's pushing down this atmospheric pressure. Then at a certain level, if we have a gradient, that means it's supposed to correlate with a 9.8 meters per second square. It's supposed to correlate the gradient that we're seeing, but we don't see that correlation. How can you correlate the acceleration of gravity with the gradient of our atmosphere?
Oh, that's a good question. There are formulas. Let's see if I have this here. So that people have formulas that predict based on elevation the pressure at different elevations. And do you know what? There's a little letter in the formulas. You know what that letter is?
No.
G.
Huh?
It's G. There's a little G.
Oh,
in
G,
there.
G, G,
Yeah.
G.
Let me see.
No.
Where did I put that?
G, the BH? No, you blaming the BH for everything. I'll tell you what. What about the electromagnetic force that is keeping the atmosphere in? Is it the G or the E?
Well, if you want, we can do that. I've been waiting for somebody to come up with the way to explain that. So can you, do you know how to do that? Because nobody has done that yet. They say, well, it could be electric, but then they don't actually go and use the formula. Because
Well, that's a question. Is it a
just,
G or is it an E for electromagnetic force?
engineer, right?
Is the electromagnetic force keeping a beautiful atmosphere plane down? Or is it the G, the BH, that you guys blame for everything?
Well,
Which one it is?
yeah.
Ding dong, ding dong. We don't know.
Yeah, we do.
Because, for example, when does the vacuum start sucking?
Vacuums do not suck.
Well, they call it a vacuum of space.
They do call it a vacuum of space, but it's not like a vacuum cleaner, right? It's actually the actual definition of a vacuum is the absence of suck, the absence of everything. There is nothing, and so if there's something near it, it wants to move into it, but it's not getting pulled into it; it's getting pushed into it.
Okay, so which is your answer? Is it gravity, the G, or the E for electromagnetic that's
Well,
pushing down or
I
keeping?
can use gravity to predict this. Can you use electricity to predict it?
No, but I ask you that. No. I ask you this one. No, I'm not claiming that electricity, electromagnetic force is keeping our atmosphere. You guys, your doctrine is claiming that, and you at the same time claiming that the G, the pH, is also doing the same thing. So which one is it in your narrative? Which is the official answer to that?
Ask that again.
Because you said that there's a force that keeps the atmosphere down, stick to the ball, right? Is it the
Yeah, it's
G or is
gravity.
it the electromagnetic force of the spin of the Earth?
It's gravity, and the spin of the Earth does not cause electromagnetic force.
Where is the electromagnetic force?
I don't know. I don't know what you're trying to claim here.
They claim that what protects us from the rays from the vacuum of space is
Oh,
an
do you mean the
electromagnetic.
Van Allen belts, or the oh no the
The
Earth's magnetic field?
the
That's yeah.
According to your doctrine, there
That's
is a molten
magnets.
iron core
That's
that
magnets.
is magnetic, and no
Yeah.
scientific laboratory can show you that magnets can have a magnetic force when they're melted.
And that's not the claim. So you should probably check up on that, because I hear flat earthers say that all the time. They're happy to misquote what it is that is the current theory for how the geomagnetic field is generated.
No. I'm the kind of flat earther that I know that is resonances. Has nothing to do with electromagnetic, has nothing to do with your GPH. It has to do with resonances, like I showed you
All
the
right.
video in the beginning.
So here we'll do this. I have I'm ready to do the math with you. All right. So I'm gonna bring this up here. We're gonna look at. There it is.
See, what I see is just pseudoscience. What the blue marble is, it's all about pseudoscience. The whole Big Bang, you don't have scientific evidence of that. It's just pseudoscience, right?
Well,
No,
I
you
wasn't
don't have.
talking
You
about the
can.
Big Bang. So, all right, I am ready. So here I have. Do you see on the screen there?
Yeah, we got 10 minutes to go
Yes.
because I got my bunny. I gotta take her for
Okay.
for dinner.
Your bunny. That's your amore.
Mi amor.
Yeah. Sorry. I think that was Italian. I tried to do. Sorry. All right. So here we
Mi
have.
amor.
Yeah. My Spanish is not very good. So here we have gravity. You see that, and then we have electrical, right? So this is Coulomb's law, if you want to talk electrical. And then some people think that pressure is what causes things to go down, but I haven't gotten a formula for that from anybody. And then, of course, there's some dingalings that think that relative density is what causes it. Of course, the same thing. AB Science tried to put some formulas to that, but it was rejected by the person who came up with relative density, or at least is a big fan of it. So we don't really have a formula for that. So if it's electrical,
I appreciate that you bringing out those formulas. I appreciate that, man. Thank you.
so I've done this, and it didn't work, right?
But at least you're trying, man. That's amazing. You're the best debater ever. You bring the best evidence ever. I think you're the closest for me to jump back into the spinning ball.
I don't know if you're serious or not, but thank you. But all right,
No, seriously, just to put the effort.
I'll do. All right, let me. I know you want to get going. I don't want to keep you any longer than you want to. So let me. You asked about what were the frequencies for getting the signals back, and so here we have the different. This is from Geist View. Always has some good information. So. View antenna, view spacecraft. There's the map. So if Madrid, Spain is currently facing towards this spacecraft, and I'm jumping into this. I don't quite know what all the detail is here. 1.32 seconds. Oh, this must be the one that's around the moon, right? Because that's about the right time, right amount of time. 1.3 seconds to the moon and back. So there you go, 65 GTL. I don't know what this is. Here it is. But I don't know. I will put this into the notes there. I'll be sure to email you the notes. I'm a little coming into that a little bit unprepared for this particular.
No, we could do round 2. That's amazing.
Yeah.
I think we could do a lot of progress in this.
Frequencies of the satellites. So
yeah, that's right. Yeah, those frequencies. I actually met the girl that takes those pictures at Mars in from the rover, the actual the department head of the lunar land, actually the Mars
lander
or rover, whatever. That little folks. Anyway, they closed the program after I asked her all those questions. They fire her. And maybe you should interview her next time you talk to her.
Yeah, if sure. Dude, who was it? Love to talk to her.
Her name is Sarah. But I'm gonna talk to her if she would like to talk to you. But this is serious, man. People are losing their jobs, man. But they got nice jobs, making $400,000 a year, and then you question them. Wait a minute, you know. All of a sudden, okay, we're closing the program. No more rover. That's it. Belly up. As soon as the head department start asking questions, flat earth questions, they give it the guillotine. They're sad.
Guillotine, yeah.
Be careful.
So, a couple more super chats because Brainy Beaver said something in French and used his Canadian money. Christ Puncher for $5 says, our money is not monopoly money. 1,000 Canadian dollars can buy a whole chocolate bar in the States, wrapper and all. And then Earth is seriously flat. Love that guy. $2. 72 people watching. Aztec calendar, perfect timing. And then he also, for another $2, says, nice try, dear Globe Zombies, but you haven't helped me. So.
Hey, thank you, brother, man. I gotta take my bunny now for dinner, and we're in Santa Barbara, California. It's gonna be an amazing day tomorrow. Thank you, MC Toon, and have an amazing day.
All right, thanks a lot. And I'll wrap it up here in a second, but I'll say goodbye to him and switch over to that. Call's done. All right, everybody. Well, I don't know. I hope that was entertaining. I figured he would have a nice conversation and it would be polite. I thought it'd be a good contrast to Joey Rocha and 33UC, who both are quite combative. Right the Hand keeps trying to have a debate with me, and I'm like, dude, you need to apologize for being rude to Karen B, who's a flat earther. But quit being rude to her. Apologize for that, and he won't. So no debate, which is fine, really, because he brings nothing. Thank you, Geistview. I will look at that. I'll try to understand that a little better. Yeah, Surf says don't bother with Right the Hand. He doesn't have anything. That's the thing. All he can do is try to say, you need to prove this, and that's not actually proving anything, right? He needs to prove it. So, Yeah, what did he do to Karen B? So Karen B, somebody posted on my Facebook page a video from Karen B, and then he commented on it with a bunch of tranny stuff and really rude, disgusting things like that, like Antonio Subarats does to what's her name? Patricia Steer. And you know, I don't have any time for that. That's pretty disgusting. So if you're gonna act like that, then you need to quit it. So but he won't even apologize. So he did that on that video, and then she posted a picture of herself and her daughter, a really nice picture. And he's such a disgusting pig that he had to go on the picture of Karen B and her daughter, this great picture, and insults her on there, and it's still there. If you want to find it, you can look at Karen B's Facebook page and find a picture of her and her daughter, and scroll down and see Chris Zielinski, that's his actual name, where he made some comment. I don't think she deleted that. I did block the comments that he made on my on the video on my page, because I can do that on mine. I can't do it on Karen B's. And anyway, so I might actually have something, a debate with Karen B. Just to kind of poke Chris right the hand in the eye a little bit. So, is there any evidence that Earth is seriously flat got a scientist fired? No. He didn't really bring any evidence at all. He talked about love makes... Hold on. This... Oh, I forgot. Yeah, this here, there's... he said love. Hold on a second. I need to update that. There's somehow 10 to the negative 13 plus love. There you go. Here's his business plan. You take uranium, you apply 10 to the negative 13, which he thinks is a negative number, plus love, turns it into oxygen, and profit. So, and that's all. Something isn't on the it's like a movie, right? You see the movies where like, this isn't even on the periodic table. You know, because the person writing the movie doesn't understand the periodic table. So it's the same thing. Yeah, find something that's not on the periodic table, collect your Nobel Prize. So that guy, quickly, he if you haven't seen, he's all confused about magnets. So he said that it's impossible to have magnets, a compass work on a sphere, which of course is silly. And I said, well, I already did it. Here's my video where I used this stack of magnets and this compass here. And you can see how it works, right? But he was all confused. He thinks that somehow a stack of magnets isn't the same as a bar magnet. And even more funny, he doesn't think that a steel rod that's been magnetized counts as a bar magnet. I don't know why. Anyway, so I said, if I can show a bar magnet inside a sphere, will you read a script for me, apologizing and whatever? And he said, actually, he came back with, I'll delete all my videos and read that to you because you can't do it at all. So he actually offered more, which is great. So I have a screenshot of that, and I ordered some magnets and a single bar magnet. I'm going to put it inside that soccer ball, or I have a soccer ball over there somewhere. Or I actually may have a clear plastic thing. So hold on a second. Case view is getting me all confused here. So a clear ball to, and then anyway, so and then he'll have to read that statement and delete all the videos because he's a goofy guy. He doesn't understand that. Doesn't understand magnetism. And if you saw Jimbo Joe did a video, or his cat did, on that guy, so it's pretty good. BM Furball. Check Discord. The other camera, my other camera is in space. Oh, all right. Let's look at that. That looks cool. So this is from BM Furball, who has always got some great stuff. So I will not do there's an ad. We'll skip the ad there. 11 minutes.
Fall of 2016, I was traveling around the US to visit some friends, and my last stop was in Florida. After a bit of scuba diving and other tourist stuff, we got talking, and I'd mentioned that I'd never seen a rocket launch. So I checked the Kennedy Space Center website to see if there were any coming up. There was going to be a launch a few days after I was scheduled to fly home, so I delayed my flight so that I could drive down and watch it. I didn't know anything about what was being launched, but I knew I was about to see a tower of explosives be launched into space, so I didn't really care one way or the other. We spent the afternoon wandering through the Space Center, ate our obligatory freeze-dried strawberries, since I was lactose intolerant at the time, then headed out to find a good place to watch the launch. The launch was scheduled for 5:40 p.m., but delays and errors kept pushing it off. As we approached the end of the launch window at 7 p.m. and the sun slowly set, we anxiously listened to the live stream of Command and Control, and waited to hear if we were go for launch, knowing it would be scrubbed if there was less than 15 minutes left in the launch window. All of a sudden, at 6:35, we hear a burst of activity from Command and Control. T-minus 10 seconds and counting. The rest of the crowd waiting on the docks all heard the call and started counting down. Suddenly, there was a blindingly bright light from across the water. We couldn't hear anything, but I stood in awe as I watched the rocket slowly lift off the ground and a hunk of metal the size of a building shoot into space. As we packed up the car to head home,
Jumping ahead
using
here.
1970s technology, we managed to receive these images off the polar orbiting satellites NOAA 15, 18, and 19, and then these higher res photos off the Russian Meteor M2. Once we'd managed that, my mind once again returned to that bright dot on the horizon, and I began to wonder if it was possible to get data off of GOES. $4.
There we go.
First we need an antenna, and these cheap Wi-Fi grid antennas work wonders, which you may notice is the face off of Pipsqueak. Then we need something to receive the signals with, and for our first test we found that these dirt cheap RTL SDRs work well enough, but later switched to my new Nesder Smart XDR, which Newelec was kind enough to send me to help with this project. We're also slowly working to develop a patch to enable HackRF support, but it may be a while. Because GOES is so far away, the signal is extremely weak, which is why we need a dish like this rather than the omnidirectional antenna we used last time. And unless we use an absolutely massive dish, we need a way to boost the signal so it's loud enough that we can actually pick it up. But if we boost just everything, it'll be drowned out by noise. So we need a combination of a filter and an amplifier. Conveniently, Newelec recently released a filter-amplifier combo for just such a purpose, which they call a Sawbird filter. They actually make 3 versions for different satellites, but the one we want is made specifically for GOES, and only lets an 80 MHz wide chunk of frequencies through, centered at 1688 MHz. Because I'm in Montreal, the signal still isn't strong enough with just the Sawbird, so I also picked up a pair of broadband low-noise amplifiers to boost the signal further. For our setup, we used an adapter to connect from the antenna to the first amplifier, which is then connected to the Sawbird and then finally to the last amplifier before it's fed into the radio. One extra mod which really helps to boost the signal is to add a little spacer between the forward reflector and antenna on the dish. I just used a 2.5 centimeter long piece of PVC and some zip ties to hold it in place, and our signal was way better. Now all we need is some software to make this work, and we'll be capturing images in no time. We use the GOES Tools programs made by Peter N., which is in turn based off of work of Lucas Teskey and the Open Satellite Project crew. There's a lot that has to be done to turn the radio noise we receive into actual info, and Lucas has an awesome set of blog posts where he goes through all of the maths required to make this work, which I've linked to in the description. To be frank, this is super outside of my wheelhouse, so it's largely over my head, but everyone involved spent a lot of time and even had a bit of help from NASA figuring out how to first demodulate, then decode these signals, and turn them into usable data. GOES Tools is made of 2 core pieces. The first is GOES Receive, which handles the radio side of things and turns the radio signal into a stream of packets. It then sends this data over TCP to the second program called GOES Proc, which takes those packets, does a bunch of math voodoo to it, sorts through them all to find out where the actual data starts, then goes about turning that data into files. The install instructions are posted on Peter's GitHub page, and I've put a link in the description. As I said earlier, we'll go through the command line stuff to make this work in a future video, but the instructions are pretty well documented on their site. One quick note is about what these numbers mean when you fire up GOES Receive. The most important number is the Viterbi, which is a measure of how clean the incoming signal is. For this to work, you need a Viterbi of less than 400, but the lower you can get it, the better. Then the RS, or Reed-Solomon value, is how much error correction the software is having to do on the incoming data. Again, lower is better. And finally, the packet and packet drop numbers are how much data is making it through and how many errors there were. You want 0 packet drops for this to work well. Okay, so we've got our hardware and software set up. All that's left is to go outside and give this a try. Now, I've omitted the overwhelming majority of footage of this, as we spent many, many days trying this with no success, as we slowly upgraded and tweaked our hardware until we found the combination of stuff you just saw. Also, and this is really important, when you go to try this, make sure you're pointed at the right satellite. The first few days we were testing this variant of our hardware setup, we were pointing at what we thought was GOES 16. We used my HackRF to validate the signal was in the right spot and looked right, and we could see that packets were coming in over TCP, but we couldn't figure out why we weren't getting any images. A few messages to Peter later, and it was suggested that the unusual number of zeros in all those packets meant that we were probably pointing at GOES 17, which was recently launched and hasn't come online yet. Now, this may have changed by the time you're watching this, and we'll be doing a video on getting some data off of GOES 17 so that we can be some of the first to get images from it, but at the time it was dead in the air. And all it did was earn me the Golden Turnip Award for not double-checking to make sure we were pointed in the right direction. See, the issue was that the Satellite Finder app I use doesn't have GOES 17 in it yet, and its accuracy isn't super great. So it never occurred to us that there could be a satellite with the identical signal in nearly the right spot. And there's only a 15-degree difference between the two. After realizing our mistake, we set up again, this time making sure we were pointed at the right satellite. Instantly, data started flowing in as soon as we set things running. The sun had already set at this point, but within half an hour, sure enough, a beautiful color image came through where the west coast was still clearly visible. Peter also just put a patch through that does map overlay, which I think is a really nice touch to help make these images more understandable. The patch just went through, so our first images don't have the overlay, but our new ones do. And with that, the story arc was finally complete. The thing I've been talking about for years at this point has finally been done. Now, that's not to say we're done with GOES. I'm still poring over all of the data we received, and we'll show some more highlights in a moment, but we have a lot more plans for GOES in the future. Before we get to the final show and tell, I just want to say a huge thank you to Lucas and his crew, and you should absolutely go subscribe to Lucas's channel.
Wow, that is really pretty cool. I'll put that in the debate overview as well. Of course, he wasn't here for it, but that's fine. So, all right, that guy, Patreons. I want to say thank you to my patrons, Dora Unku, oh my god, Tom Miller, and Stringer News 1. Thanks a lot. If you want to be a patron, mctoon.net/ patreon.com/mctoon. And that's about all I have, unless anybody else has anything they wanted to say. But I'll put one more time. I'll put the notes from tonight in here. So there you go. BM, pack up your amps in dry ice. It will improve the sensitivity at Goldstone. We chill our receivers with liquid helium. Brainy Beaver, I'm not. You aren't far from me. We should meet sometime. Yeah, I'm in Minneapolis, and you're in France, right? Where? No, I know you're not in France. You're not in Quebec. Golfing, Manitoba. I've been to Banff twice, and I'm gonna be in Minnesota next month. Christ Puncher, cool. Straight north of North Dakota. Where in Minnesota are you gonna be? Christ Puncher. Oh yeah, I got this from the Dakota. Yeah, I knew BM Furball. You were from the Dakotas. You're in Colorado now, right? I posted today here it is. I'm gonna bring this up here. So I was in Anchorage last month. So Crest Puncher, let's see. Where are you gonna be in Minnesota, Crest Puncher? All right, let me. There is do it in a different browser here. So you see it as I see it. That's not it. Well, anyway, there is the tweet that I put up today when I was flying back from Anchorage. Took a picture of the moon with the Theodolite app. $5 well spent. You can see the moon is below eye level. The horizon is below eye level. And I have GPS coordinates at 35,000 feet over the Yukon Territory, where there isn't a whole lot of cell phones anyway. So it tends to ruin a whole lot of flat Earth arguments in one go there, right? You know, GPS is ground based, except it worked just fine at 35,000 feet, and I had no cell service. And the horizon isn't where they say it is. So there you go. That's all I have. Thanks a lot, everybody. I'm gonna wrap this up and be done with it, and we'll catch you next time.